This video is a quick introduction to the breadboard and goes over some quick troubleshooting tips when working with breadboard circuits. Breadboards are pretty handy prototyping tools that allow you to create quick circuits. Really, the three main things to know about a breadboard, and that is so these horizontal strips, they are electrically connected. So for instance, this pin and this pin and this and this and this, these are all electrically connected that way. And then on the side here, you have these long strips there that are electrically connected as well. So this whole line there is connected together. This whole line there is connected. Same thing on this side. And then the third thing is that this separation in the middle here, there's no electrical connection from this side to that side. So inside here, these are connected row-wise, and then outside these are connected column-wise. And that's really all there is to know about the breadboard in this sense. So breadboards come in all shapes and sizes. So you have the small ones like this, and you can actually stack these small ones together. They plug in together like that, so you can keep building them up more and more like that. So you have that size. You have bigger ones like this, which allow you to build bigger and more complex circuits. And you have some long ones like this. And then you have this more standard package here with banana plug connectors. So as you can see, there's all sorts of breadboards and sizes. And then this breadboard here allows you to see the connections I was talking about in the back. So you can see these horizontal strips are connected together, but there's a separation in the middle, and then these vertical strips there are connected together as well. In order to demonstrate some best practices and troubleshooting techniques, I've gone ahead and put together a simple 555 timer flasher circuit. I've adjusted the resistor values so that the circuit blinks the LED on and off slowly. Now, in order to demonstrate the troubleshooting steps, I've gone ahead and messed up the circuit a little bit so that we can go through and try to figure out where the mistakes are and develop a little bit more intuition about troubleshooting breadboard circuits. The first thing I'll say is when making circuits on a breadboard, you want things to be fairly neat. So you want to keep your wires short, and as much as possible try to use a consistent color scheme. That means maybe red for power and black for ground. In this case, I'm using yellow for ground just because I didn't have a short black wire, but whatever you do, try to be consistent. And then for my signal wires, I'm just using brown wire there. And as you can see, my wire lengths are short there. So if you're making a circuit and then you're using long wires like that, I'm just kind of randomly placing wires. So if you end up doing something like this, your circuit will easily become messy. So like if you're using long wires like this, it becomes harder to get in there and fix things or to access components. So you generally want to avoid having long wires just because it'll create a rustiness of wires and you have a hard time troubleshooting your circuit. Okay, so right now my circuit is plugged in and I've applied power to the power rails and nothing is happening. So the very first thing I'll do is, well, first of all, check the obvious things. Am I actually getting power where power needs to be? So for the sake of this video, I'm going to use a logic probe. So you typically would use a multimeter to check for continuity or power at different areas, but in this case I'm going to use this logic probe, which once I tell it what the logical high and low are, so I've just connected it there to my power rail. Now if I touch the logical high, the red light will blink, and if I touch the logical low, the blue light will turn on. So in this sense, I can kind of see where things are. Now, looking at my circuit, I know I'm supposed to be getting power to pins 4 and 8, which is also the first resistor there. So I'm going to check pins 4 and 8, and then just looking at this circuit now, I see that my IC is backwards, because every IC has a little dot or circle or some indicator that shows where pin 1 is, and right now my pin 1 is there, and I know when building this circuit I had it with pin 1 being in the top left there, and that's usually best practice as well. You always want your pin 1 to be in the top left when you're looking at it, just as a good standard, one might say. Okay, so I'm gonna remove power from my circuit, which you should always do before making changes, and then I'm going to pop out this IC, being careful not to bend the pins, and then I am going to flip it over. Can be a little hard to get in sometimes. The pins need a little bit of work. Okay, so our IC is back in there. Now we can go back to testing. Alright, so I need power at pins 4 and pins 8. So I'm gonna check, let me start with pin 8 over here. Interestingly, pin 8 is showing a logical low, and same thing for pin 4. So I'm gonna take a look at here. So this is giving me a logical low, yet over here I'm getting a logical high, the red light. So this illustrates one of the most common errors, and something that can trip you up. So on these long breadboards, there's actually electrical separation between this top power rail and this bottom power rail here. Now if I flip this over, you can actually see this down here. So you see this bus here, it's electrically isolated from this bottom part there, and the same for this middle section here. So for these big breadboards, if you're going to be plugging into the bottom section here, you want to make sure that you have a jumper going from here to there, or that you connect everything on one side. So with that in mind, I'm going to remove power again, and then I think I'll just move this wire over to this end. Alrighty. Now let's check again. And we're getting our power there, positive at the pin. The red light is still lighting. And there. Okay, so looking at our schematic, we have power going to pins 4 and 8. That's good. Let's check ground. So we have ground going to pin 1. So if I just check pin 1. Okay, pin 1 is showing a logical law there. This end of our LED is also connected to ground, so that's fine. And we can check the polarity of our capacitor. That's also going to, this side is also going to ground. Okay, so our ground connections are good. Now let's check these. Let's check the junction for pins 2 and 6. So we know pins 2 and 6 are connected together. So pin 1, pin 2 is there, and then pin 4, 5, 6. That's also connected to the low side of the circuit, and I can just visually see the wire going there. And then pins 4 and 8 are also connected by a wire. So I'm gonna check there and see, okay, that's connected. So that side of things looks fine. Our circuit is still not working. So then I'm gonna kind of start taking a look at some other components. I know my capacitor is already in the correct polarity. I have negative, which has this white stripe there. That's going to ground, as in our circuit. And then positive side is going to pin 2, which it is. Okay, so let's take a look at our LED. So I'm just gonna remove power again. Then I'm gonna take the LED out. And right there, I noticed that the LED is put in backwards because I'm using conventional current flow. The current flows from the anode to the cathode, so it flows from the long lead to the short lead. And in this case, it looks like I had it in backwards. So I'm gonna go ahead and flip it over so that the long lead is towards the signal side and the short lead is towards ground. So I'm just gonna go ahead and put it in there. And all right, we're getting somewhere. So I've actually gotten the light to turn on. So that means we have one more problem in our circuit here. Now the next thing that you always want to do is make sure you when you're plugging in thin wires like resistors, it's very easy to put them in an incorrect spot. So in this case, I'm just checking to see that the resistors are actually where they're supposed to be. And then right there, I've noticed that this resistor is actually connected to pin 8 instead of being connected to pin 7 as the circuit shows. So I am just gonna move it over to pin 7, and then let's try that again. Alrighty, so it looks like we've figured out all the issues with our circuit and we have a nice slowly blinking circuit. And just to summarize, like when your circuit isn't working, you always want to start with the obvious, check that you're getting power, and then referencing your schematic or circuit. You always want to work from a schematic when you're building a circuit. I know some simple ones you can easily build them from your head, but even so, when troubleshooting, it's much easier to have a schematic to reference. So in this case, you can see which pins are connected together, and it just helps you stay on track. So yeah, you want to make sure you're getting power where it's supposed to be. Check your grounds, that all your grounds are connected together. And then if all that's good, do the obvious. Check to make You want to check to make sure that your IC, if you're using an IC, is connected properly. And you also want to make sure that your IC is connected across this bridge, because as I said, looking back here, uh, these strips are electrically connected and your IC needs to be across there, because if you put it there, you're going to short all the pins together. So you want to make sure that your IC is actually connected across this bridge. You want to make sure that you're actually connecting all the junctions together in the same row. That's quite important. It's easy to misplace a wire and put it accidentally one way or another. For your polarized components like your LEDs and capacitors, you want to make sure you have the correct polarity, especially for electrolytic capacitors. Then the final thing, and this is something that can be really, really hard to diagnose, is if you're using a resistor from one of these packs. As typically when you buy a resistor set, they would come in something like this, and then you just pull the resistor out. When using one of these, you always want to make sure that you completely remove the adhesive from the ends of the resistors, because the resistors are held in place using an adhesive there. So you want to make sure you absolutely remove any trace of the adhesive there before putting it in the breadboard. If you put it in the breadboard with the adhesive there, it can gum up the connections and give you an intermittent connection, or just for the sake of resistors, you'll be getting wrong resistor values because it'll add resistance to your circuit. And if your circuit relies on precise resistances, that can really mess you up and you won't be able to figure out what's going on. So just remember to remove the adhesive from these, or just cut the leads a little bit shorter there, and that'll save you a lot of time.